Measuring things, large and small, has always been an important part of any production process, but it is also time-consuming and costly. In the smart factory of the future, in the Industry 4.0 factory, measuring becomes even more important if it is inline, flexible and cost-effective. Today we're going to talk about measuring, and we talk to someone who knows that size matters. Andreas Gerster from Faro Technologies, welcome to the business debate. Faro is essentially doing measurements, and measuring is unsexy. Why?
Typically people don't want to do any measurements because it's time consuming, it adds cost to a manufacturing process or to whatever process. That's why people typically try to guarantee quality by design versus measuring the quality in. So per se, nobody does really want to do measurements.
In how far does Faro help?
We are really helping in multiple ways. One way is certainly to make the measurement process cheaper and easier to handle. This is not just the equipment price, this is really the effort needed to train people to use those instruments. And then number two, ideally, you would be able to do the measurement without disturbing any other process this is running. And we are able to do that, for example, for the construction industry, using laser scanning technology that doesn't interfere with the construction process, or providing inline measurements down to the micron accuracy for automated assembly lines, for example.
Why is that this inline, that's a key word, isn't it? Inline measuring. Why is that so important?
Yeah, inline or nearline is so important because it allows you to really provide a fast response to potential quality issues. So the traditional approach is you take a part out of the assembly line, you send it to a measurement room, you have a huge coordinate measurement system there, expensive, difficult to handle. And is essentially doing inline measurements is a key thing in the end, because that would not disturb in any way the manufacturing process, and it would allow you to have a closed control loop. If you measure every part, you can basically instantly respond to any potential quality issues.
Why, you say that Faro is Industry 4.0, that Faro is the smart factory. Why is measuring becoming more important now? Because parts always needed to be measured. What is different now or in the future?
There is one manufacturer who has a headquarter here in Europe, and they really are able to produce any car model on any of their about 10 assembly lines and factories they have around the globe. That was actually a key element to them.
So to get this right, they can produce sort of a small compact car or a big SUV on the same production line. How do they do that?
They actually have a digital twin of all their factories in the computer. So they don't just simulate the design process for the car itself. They simulate the entire assembly process from the last to the first screw. And that means when they add a new model to the assembly line, they really have the whole infrastructure in the computer, and they can ensure that they can make any change to the assembly line that is needed to handle this new car model without this interfering with any of the previous models. And the only way they can do is they have implemented this element of a smart factory, because they don't just control the individual process steps, they control the entire environment, including the infrastructure and the building.
And that ensures an incredibly high productivity.
Absolutely. They do that using our laser scanning technologies along with our software tools.
Talk about laser scanning. It's not just about cars or producing mobile phones. There's medical applications too, you told me.
Yeah, in the medical area, this idea of creating individualized products becomes a key, because obviously every human being is different, and when you have a medical treatment, you hopefully get a treatment that is really adapted to your needs and your case. So one example where Faro is engaged is in the area of brain surgery. When you do a brain surgery, obviously you have to open the skull, and later on you need to close that hole again. So today you have to do that with 2 surgeries actually, because in the beginning this hole is only closed with a professional tool, and later on an artifact is produced, and this artifact is then used to close that hole in the skull. Using Faro laser scanning technology, you can actually do a scan of the opening in the skull, and while the first brain surgery is still going on, you can print an artifact on a 3D printer that is able to work with biocompatible polymers, and then use this artifact to close the hole within the first surgery, so that dramatically reduces the risk for the patient.
Okay, we've talked about the car industry producing small products, but there's also a use for measuring in the construction industry, for example. What does the construction industry 4.0 look like?
Just recently I attended a large conference in the Stuttgart area, and we had a famous professor from the construction industry, and he said, you guys, you talk about Industry 4.0, I have to tell you, in construction we are dealing with Industry 1.2. If you just think about the prominent examples like Berlin Airport,
Oh yes.
There is no other industry in the world that would accept schedule overruns, budget overruns, and the amount of waste and rework that is just accepted today in the construction industry. No other industry in the world would accept that. Really the challenge is to have a closed loop of quality assurance, and quality starts obviously with the planning process. Planning today in the construction world is oftentimes it's paper. You have of course you have a 3D model in the computer. You can't have the computer on the construction site. It's dirty, it's muddy. Okay, so you print on paper, you hand it over to the foreman, and they do the job. And only later on you might find out, hey, there is a pillar. This was supposed to be 2 meters over there. There was no way to identify that. Okay, so you have to plan around, you have to replan, you have to rework. Using Faro 3D scanning technology really allows you to have a digital twin of everything that happens on your construction site at every given point in time.
So you have a constant measurement there.
We have a measurement process that is so easy and can be operated by relatively untrained people. So you can actually do constant continuous scanning if you like, and then you can on a daily basis check what happened on my construction site today. You can automatically compare the 3D data that you gain using our instruments on the construction site, compare it with the CAD model in the computer, find any deviations. You can even do that in situ. So one example is concrete pouring. So the traditional approach is, if you think about a large floor plate, the concrete is poured, then you wait to get it, to make it hard, then you bring your measurement gear on site, and you say, okay, I have too much here, I have too little there, so you have to start to do the rework. Concrete is hard, so that's a lot of work. Using scanning technology, you can actually scan the pouring process while the concrete is still wet, which allows you to do any adjustments and changes on site while everything is still workable. That saves a huge amount of time and cost. It's just a very simple example, but that works along the life cycle.
So from building cars, building whole factories, to drilling holes in skulls. Thank you very much, Andreas Gaster from Faro Technologies.